All right, so no doubt with any multiple choice, it's easy if we can make use of our technology, right? So in reality, if we think through the process here, we've got our acceleration. So to find our velocity, we integrate that. So if we just go through the long process, we integrate the velocity, we get a constant, we substitute our initial condition in for the constant, and we end up with c is equal to 50. So that becomes the velocity equation, and we substitute t equal to 1 in that to get the velocity at that point. Now, if we remember our integration notation or integral notation, this is an equivalent expression for all of that. 0 being that at t equal to 0, okay, that's my initial condition, all right? And then because we started from rest, I don't have to worry about adding any other constant. So what this does here, okay, because we've got our variable here in t, what this actually does, it works out the antiderivative, substitutes t in, so you get an antiderivative in terms of t, and this 0 here then works out basically the initial condition, all right? So then by putting t equal to 1, we get our final answer. So I guess that notation form of that integral notation form is just a more succinct way of working out my antiderivative, working out my initial condition, and then substituting a t value in, okay? Number 2, again, there's my acceleration. So again, if I work out my antiderivative, okay, there's the antiderivative of that function. And then if I want to work out the antiderivative of the next one, so there's my velocity, then work out the antiderivative again to get my displacement. And there's my equation there for E, all right? What are we doing? Similar sort of thing. Okay, we've got a velocity there, and there's the velocity is equal to that. For what times of t does the particle first attain its maximum speed? So when's the maximum occur? When the derivative is 0. So let's find the derivative, which is there, solve it equal to 0, and I get pi plus pi on 3. Now, interestingly though, the trick in here, if we actually look at the graph, what our derivative, remember, finds is our maximum and minimum. But because our graph is shifted, a maximum here at pi on 3 is only 1 meter per second. Whereas at 4 pi on 3, it's down here at whatever that is, -3. So the maximum speed actually occurs at the second point. Okay, so that's really important, all right? All right, let's have a look. Question 4. Okay, a little bit of trial and error. Particle moves, constant acceleration in a straight line. Which one of the following could not be true? So in other words, which one of the following is not going to give me constant acceleration? So some of them are really quick. If I come down to v and work out dv dt, which is acceleration, dv dt is equal to 1, constant. Similarly, what's another quick one to work out? What about d? I guess d relatively quickly. V squared is equal to x plus 1. A half v squared is equal to half x plus a half. And the derivative of a half x squared with respect to x, d dx of a half v squared, that's another form of acceleration, gives me a half, constant. All right, so we've really got to check it. The first one, v is equal to t plus 1, dv dt is equal to 1, so constant. Yeah, so it actually works out that b is the one that's going to give me a non-constant acceleration. So if I work out dt dx, which is 2x, that means the velocity is equal to 1 on 2x. So then velocity squared is 1 on 4x squared. A half v squared is 1 on 8x squared. The derivative of that gives me -1 on 4x cubed, which is not constant. That's going to be dependent upon our position. All right, so B is the answer there. again, it's velocity, watch, this is the velocity time graph over here. Which one is my acceleration time graph? So clear cut, acceleration is the gradient the whole time, so we're focusing on the gradient. So clearly the gradient of the graphs between 1 and 3 is 0. So in fact, all of them, except all of them just about qualify, so we can eliminate one. The next one is, well, what about the gradients? So the gradient between 0 and 1 is positive, and the gradient between 3 and 4 is negative. So it's got to be positive at the start, negative at the end. Okay, so what fits? So positive then negative. So positive then negative. So it could be E. It could be B, positive then negative. So now we've got it down to A and B. Clearly, the straight line at A means it's a constant acceleration, isn't it? So it should be a vertically straight line. So it should be a y equals mx plus c line at the start and at the end. So it can't be B, so it has to be A. Okay. Let's work this one out. Balloon is rising vertically at constant speed. Undo. Constant speed of 21 meters per second. A stone is dropped from the balloon when it is h meters above the ground. The stone strikes the ground 10 seconds later. T is equal to 10. So I'm going to change this a little bit because it's about the stone. So my stone has initial upward velocity of 21, which is against the direction of motion. It's got an acceleration downwards of 9.8 meters per second. And T is equal to 10. The value of H, we've got to find H. So what do we know? We've got V equals, we don't want V equals U plus AT. S maybe, S is equal to UT plus a half AT squared. Looks about right, doesn't it? So S is equal to negative 21 times 10 plus a half times 9.8 times 10 squared. So negative 210 plus 4.9 times 100 is 490, which is 280 meters, isn't it? B. Okay. Particle moving, again, x is equal to the velocity at second times per second, and the minimum value of v is, so I guess we can work out the derivative of dx, so v is equal to dx dt. So we get 2.5 minus 4.5 sine, yeah? And when does that minimum value occur? When sine is equal to 1. So my minimum value is going to be 2.5 minus 4.5, which is equal to negative 2. All right. Particle moves, A is equal to 16x, and V is equal to the relationship between V and X is. So we're find a relationship between V and X. So we're going to use either V dV dx or d dx of a half v squared, and I've gone with d dx of a half v squared. So we integrate both sides, I get 8x squared plus c, put my condition in, we get 25 on 2, so v squared equals, so v is equal to plus or minus. Now which one are we going to use? At x equal to 0, v is negative 5, which means I have to have a negative sign out the front, which makes it c. All right. What have we got? A particle travels a straight line with velocity v. Velocity is given by the acceleration. Again, I've got my velocity. Acceleration is v dv dx. What have I done there? So d dx of, so in this case, I've gone the derivative of v is that, and then I've multiplied it by v, which is there. So in reality, what I've worked out is dv dx times v, which is another form of a, okay, which gives me c. Okay, again, an equivalent, I could have worked out, I could have done a half v squared is equal to a half times 4 over 1 minus x squared, and then worked out a derivative of that with respect to x. Okay, so two approaches, both should give us the same answer. Okay, this one here, the key is to note that, what have we got? Particle travelling, so there's my particle, dv dt. The time taken for it to decrease. So I want t, don't I? So if I work out my t value, so there's dv dt there. If I then work out t, flip it upside down, integrate with respect to v, now I'm decreasing from 2 meters to 1. Often we talk about how the long it takes, our particle normally increases from 1 to 2, yeah? So in this case, we're decreasing from 2 to 1. So my terminal points are the opposite way, all right? So the common mistake, and I suspect I did it at one point, was to go with A, all right, because you're not thinking about the motion of the particle. Particle moves in a straight line, so that dv dx is equal to 1 on v. Again, a couple of ways we could approach it. V times dv dx is acceleration, so 1 on v times v is equal to 1. So I have constant acceleration. Okay, so it's one of those three. If dv dt is equal to 1, integrate both sides, I'll get v is equal to t plus c, and v is equal to t plus c, means I'm going to have increasing velocity. So that's B. Okay, particle travelling a straight line given by dv dt. We've got some initial conditions, so again, I'm going to flip everything upside down. T is equal to the integral of 1 over that expression. 1 over 0.05 is 20, so I've got a negative 20 out the front. I want to get an expression for the time, so I'm going to integrate this thing between 0 and t because my initial okay, we're finding our time. Okay, so there's the expression for my, there's the expression for the time in terms of the velocity, yeah? Now, I want to know the time it takes for it to change velocity from 50 meters per second to 3 meters per second, yeah? So it's going to change from 50 meters per second to 3 meters per second. All right, which means if I flip the terminals and bring the negative sign out the front, I get a positive 20, okay, which is going to correspond to B. All right, so again, it's just thinking about those terminals and which order or which way our particle is changing. 13. A lot of these were just straight on the calculator from memory, I reckon. So there's my velocity, the acceleration of the particle. Okay, so I started going with, instead of going v dv dx, which I could have done, so I could work out dv dx, derivative of sine 2x, and then multiplied by v again. I've instead used my CAS, v of x equals sine 2x, d dx of a half v squared gives me 2 sine x cos x, which is sine 4x, 2 sine 2x cos x, yeah? And then, now that I had on the calculator, I just kept changing it. This time round, the derivative is the velocity is sine inverse of x. So d dx of a half vx squared is sine inverse of x over 1 minus x squared. Again, you could work out v dv dx and do it that way. What have we got here? Velocity. the acceleration of the body. So what is acceleration in terms of v? So acceleration is equal to v dv dx. V is equal to f of x, dv dx is sf dash of x, which gives me e. Nice velocity time graph. After 10 seconds, the distance of the body from its starting point. So area, positive area that we've travelled, positive area that we've travelled. And I'm colouring in, I've got it, minus negative area. Yeah. So our negative area was 25 on 2, our positive area was 10 plus 20, and that leaves me with 17.5. All right, body moving in a straight line is given by v is equal to x. Find the rule relating x to t. So again, so what are we saying? We've got, I'm saying that v, oops, I'm saying that v, which is dx dt, is equal to x. So in other words, x dashed is equal to x. So I could go through the integration process, flip it upside down, all that sort of stuff, but I've got d solve as well. X dash is equal to x, my initial condition, at t equal to 3, x is equal to 1, and so I get x is equal to e to the t minus 3. Okay. 19, object moving in a northerly direction at a constant rate of 2 meters per second. So I've got the velocity with a constant acceleration, sorry. So d dx of a half v squared is equal to 2. So I want the initial velocity of the object 100 meters north. So my variables are v and x. So I could have gone with dv dt, but I want to work with v and x because x is my variable. So again, integrate both sides, I get 2x, initial conditions, put my values in, and we end up with a plus or minus 10 on 10 root 5, which is A. Acceleration is given by blah, blah, blah. Okay, so again, I've got, so what are my variables this time? V and t, so I've got dv dt equals. So I can just put, it's easier for me just to put v dashed and then solve it on the DE solve. I could flip everything, integrate, etc., but it's a bit trickier with the natural log v and v. So it really is a CAS one there. Put my initial conditions in. And if we put our initial conditions in, yeah. So if we put our initial conditions in, if we put conditions in, we get v is equal e to the positive square root, or we also get e, and that I haven't put the rest of the calculator printout there. You get e is equal to e to the negative square root. Okay, which is both of these options. So which one? If I put t equal to 0 in, I'm going to get e to the square root of natural log 5 squared, as I've written over there, or e to the negative square root of natural log, etc., etc. This one here gives me 5 as an answer. This one here gives me 1 on 5 as an answer. Okay, so when we get that square root plus or minus, which one is it? Typically, if we substitute an initial condition back in, it'll eliminate one of them for us. All right. Let's keep working through. The graph shows at the end of 30 seconds the position of lift is. So again, it's working at some areas, isn't it? So we've got a half A plus BH. So 15, 5, a half times that gives me 30. Area of a triangle is a half base height. Don't forget, so my base is 10. My height is 2.5. So that gives me 50 on 4. So 30 minus 50 on 4 is 70 on 4, which is 35 on 2, which is A. Last multiple choice. Again, body moves V is equal to the acceleration of the body. Again, it's another one of those ones where I can work out V times dV dx, or just d dx of a half V squared. I define V equal to, work out d dx of a half V squared and get negative 4x. Righto, multiple choice done. Nearly done. All right, again, I've got V is equal to 25 plus x squared. If x is equal to 5 initially, then t is equal to. So again, I've got dV dt equals, dx dt. So I've got dx dt equals, so I can write that as x dashed is equal to 25 plus x squared, use my DE solve facility, and come up with an appropriate equation. Okay? Now multiple choice are done.